Hello. So this is the part two of today's podcast, where we'll discuss development of cryptocurrency and how do they actually work. So as Surya told in the previous part that cryptocurrencies are not regulated and are different from normal currencies. So what actually are cryptocurrencies, and how are they different from normal currency that we use in our day-to-day life? So the normal currency that we use in our day-to-day life is called fiat currency, or the for example, the Indian rupee or the dollars, or the if we are swiping our debit cards or doing net banking, it is all done in a currency denomination of fiat currency, which is regulated by a central bank or a federal authority, a centralized mechanism to control currency. So like there are three different types. So one is the normal currency, the fiat currency, or the notes that we use or the coins that we use, which is the hard currency. And then there is a digital variant of the same, or electronic money. For example, when we are using our debit card or when we are using net banking, we are not actually exchanging currency notes, but we are transferring it digitally from one source to another. The same may be also like a digital format or variant of money could be the loyalty points, for example, or the points that we store in certain loyalty programs, like for example Starbucks, where we use our fiat currency to buy certain points or deposit it in a card which is exchanged for a certain commodity, for example coffee in case of Starbucks. So digital money or electronic money is still in dealt in the denomination of fiat currency, but cryptocurrency, why it is different is it is not as Surya told, it is not backed by a sovereign guarantee. So it is not backed by a central bank or any authority. It is just a decentralized way of managing finance. So a popular term these days is also DeFi, DeFi, which is short for decentralized finance. There are a lot of advantages as well as disadvantages of cryptocurrencies. A lot of advantages that are like, unlike normal currency, when we travel from one country to another, we have to uh, exchange currency. There are certain transaction costs associated with it, which we deal with cryptocurrencies. There is no geographical boundary associated. Same way, when we are transacting with a bank, we pay some transaction charges. Whenever we are getting some credit, we pay certain transaction charges. All those things make up cost a certain amount of fees and all, which is not necessarily used in the actual purpose, but it is used for maintaining the entire infrastructure of finance and currency and banking system, to manage the regulatory environment and all. In cryptocurrencies, these transaction costs are next to zero. So they are very minimal, since there is no central authority, there are no salaries to be paid, there are no buildings that are managed, all those things. So in this, I will cover some of the advantages, what are the advantages of these, and how do they work. So I mentioned centralized and decentralized, two words. So when so cryptocurrencies are decentralized form of tokens, and whereas our fiat currency, for example our rupee note or a coin, or in any way we are dealing in any of INR denominated any instrument, these are centralized and regulated by our central bank, Reserve Bank of India. And so any transaction which is done using rupee has a sovereign guarantee, which is backed by Reserve Bank of India, and the value of rupee or its inflation or deflation can be controlled by the central bank using different processes. For example, controlling the repo rates, controlling interest rates. They can control the inflation or deflation and manage the economy, or for the lack of better words, artificially manipulate different aspects of economy and fine tune it for growth, in case of India. So when I say decentralized, there is no central authority in cryptocurrencies which is controlling or fine tuning all these things. It is a just a demand supply thing. There are a certain number of tokens which had been created, which are generally created at the time of starting of a cryptocurrency, which is also termed as genesis, or the first block or the first item in the ledger that is there in cryptocurrencies. And those the pricing of those tokens fluctuate on the basis of demand and supply in the market. And there are certain rules written in algorithms which control the creation of new currency. So since a finite number of currency may exhaust its functionality at a certain point of time, so there are certain algorithms which allow generation of new cryptocurrency. So everything in a decentralized system, like in case of cryptocurrency, is regulated by algorithms which have been well thought of in a lot of aspects, which we'll go through as we go in this part too. So decentralized, when I mean, it is that there's no single geography, there's no single person, there's no single computer which is controlling these networks. For more clarity, I'll use Bitcoin or blockchain at most points in during my presentation, but that can be extrapolated to other kinds of cryptocurrencies or other kind of networks which are existing for cryptocurrencies. Just for clarity, cryptocurrencies other than Bitcoin are generally called altcoins. Why we focus a lot on Bitcoin, or what is the importance of Bitcoin, is that it is one of the first cryptocurrency which deployed all these systems in 2009-10 and has been like running till date without any attack which has caused a destabilization in the core concept of the cryptocurrency, blockchain, Bitcoin, those things. So the decentralized means that there are multiple people, or which are called, the technical term is nodes, which are controlling this network. When I say control, it means that they are participating in building this network. So if one node switches off, or say all the nodes in one particular country, because of regulations or because of any other aspect, are switched off, it does not hamper the system. The system will still continue with the other nodes. It does cause an impact on the performance or of the network in terms of, say, the reliability and all, but still it is very difficult to switch off this decentralized network. For example, it would be like for controlling Bitcoin or switching off Bitcoin, it will be equivalent to, you'll have to switch off internet to get everyone off from the network, and that will only cause it to switch off. So decentralization raises certain other questions. First of all, how does it work? Why should I trust other people whom I do not know in the entire network? Why should I trust them with the token for which I am paying in fiat currency? I am essentially exchanging my fiat currency's value for certain crypto tokens. And is it reliable? So what guarantees that there's no central bank, so I'll not lose my entire money in essence? So how it works is, there is a ledger equivalent of cryptocurrencies. So ledger is generally an accounts of what is coming in and what is going out of in a financial transaction. So all those things previously in ancient time used to be in books, then it went to databases and all when banking system and the IT system came up. And the cryptocurrencies also use something similar called a ledger, which gives birth to this blockchain. So blockchains are actually distributed systems of ledger which help in maintaining these decentralized systems. So they're popularly known as DLTs, distributed ledger technologies. And there are a lot of advantages of distributed ledger technology. Unlike us, there's no single point of failure in such things. So even if one node is compromised, which is contributing to this ledger, there are several other nodes which can come to a consensus and kick that alteration which is not legit out of the system. They can even kick out a particular node which is acting maliciously in a lot of transactions based on algorithm. And everything is like, now how to take care or how it maintains, like, is it done manually or is it done algorithm wise, or if it is using algorithms, how it is done. So the distributed ledger technology or the blockchain is a very beautiful piece of technology which has got a lot of applications, and biggest one being cryptocurrencies. Just to give you a scale of importance or of these algorithms and what they are currently sitting on, the entire cryptocurrency market is worth more, like the market cap is today more than 1.2 trillion dollars. The topmost cryptocurrency Bitcoin today is $671 billion plus of market cap. The next highest market cap cryptocurrency is hovering above $200 billion. And yeah, that is the scale that we are looking at. That is the amount of trust that people have combined all together, put in these technologies. So what is blockchain? So to understand it, it is like there's a chain of different blocks which are all together called ledger, and this is distributed among a lot of nodes or a lot of stakeholders across the internet. Anyone who has a computation power or a computer can be a part of the node. He can be a part of node as a just a person who wants to get access to this blockchain, can be a part of this node to do transaction, can be a part of this node to support the system of blockchain by acting as a miner or showing proof of work, which we'll come to what it is later. So how this ledger maintains itself, that it brings to the next question: how this ledger works across these nodes. So what happens is there are certain terms which I'll come to in the coming questions, like how do we ensure that it is there are no maliciously acting nodes which are taking the system down? Why should we trust others on this blockchain, which I just now raised the question. And recently it has been a very debatable thing that how does energy consumption come into play. So what essentially a block means is it has a lot of data around transactions. So in case of a blockchain, a Bitcoin blockchain, so I will typically talk about blockchain, a Bitcoin blockchain, which can be scaled to other kind of data or other kind of applications as well, which Jaivardhan will touch upon. So consider each block as an entry in the ledger. So in case of Bitcoin, it contains who, from whom the transaction is from to whom the transaction has been from like who is the beneficiary of the transaction and what is the amount of the transaction. And these from and to do not contain the names of people or addresses of people. They contain a public key, which is a numerical number. If I am transferring something to Surya, from would contain my public key, which is the numerical number. 2 will contain Surya's public key, and no one can associate it to us personally unless we make it public that okay, this public key is from Surya, this public key is from Anurag, and the amount of Bitcoin. And using this, there is a mathematical functionality called hash generation, which converts all. For example, I'll use the for example, SHA is the hash that Bitcoin blockchain uses. So it converts irrespective amount of data, type of data, what is there in the data. It converts it into a finite number of characters mathematical equation. So for example, what you can see E2C 52 something like that. So there will be the same length of string, and irrespective of what is the amount, who is transferred it to whom, what was the date, that is the hash that is generated of the block, which is again stored along with this data. And there is also a hash of the previous block which was there in the data. So if we consider this block as a ledger entry, so if you'll see this fourth image to the right bottom, you'll see that there is a chain of blocks that get created, and each block contains the data in terms of transaction data, the hash of the previous block, the hash of this current block. And to make any change to any of the ledger entry, you have to make changes across the blockchain, because each block, what I told, contains the hash of previous block. So if you make any change in a block, maybe it may be a single character. So for example, from $100.0 you make it to say $99.99, it will change the hash, and you'll have to change the entire block chain which is existing after that block. And this is essentially what all these nodes existing on the network do. So how these nodes act and how it all started, like it all started when like this concept has been in existence from around 1991 92 of creating such networks where people can come to a consensus to that what is the correct last block which get added to the blockchain, and that entire blockchain is now synchronized across all the nodes in the system. So everyone has the same ledger now, and the new block, whenever it comes, it gets approved by majority of the people in the entire network. It gets synchronized across all the nodes, and that is how this synchronization happens, and everyone gets the latest correct copy of the ledger. If someone has the last block which is not correct, the system kicks that alteration out of the node. It is not considered as a legitimate ledger, and it has to be synchronized with the current legitimate ledger. So this ledger is decentralized across the globe, for an example, in case of blockchain. But what happens if a lot of people get together and want to attack this system? So as we know that there is 670 billion plus dollars associated with the market cap of Bitcoin. So it gives the economic incentive for someone to attack and alter it and transfer it to some personal account and take that money out. So like this, to counter this, the entire logic is based upon Byzantine fault tolerance, which comes from a famous theory called Byzantine generals theory, where there are a lot of nodes, and here the analogy in the original problem was that there are a lot of generals who have to attack a singular enemy, and they have to do it in a synchronized way to attack and win. And what happens if there are certain traitors, or there is certain messages which are not passed in time, or the messages get altered while passage, or certain nodes act maliciously and are traitors in the system? So there is a certain threshold which needs to be achieved in terms of blockchain for certain, or for these malicious nodes to attack the entire system. For example, it is more than 50%. So more than 50% of the nodes, if they act maliciously, then yes, they could act in cahoots and alter the last blocks and alter the entire blockchain. This is where it comes now, how to counter this. So blockchain or any kind of such digital distributed ledgers are based on certain algorithms, mathematical algorithms, to counter such problems, which make this cost of attack higher than the economic incentives that could be reaped out of such attacks. So how does it work is, for example, Bitcoin's blockchain works on a concept called proof of work. So we'll talk about two such concepts: proof of work and proof of stake. Proof of work and proof of stake are the two most famous these mathematical algorithms which are in use today in terms of blockchain. So how Bitcoin works is, there is a particular proof of work that needs to be done by the nodes to approve a final block in the blockchain or in the ledger, which gets synchronized across the board, across all the nodes. So what happens in there's a term used, miner. So miner are people who contribute to the proof of work and verify or validate these ledgers or blocks which are get added to the blockchain. And what happens in this mining process? What happens is they receive that final transaction, and then there are certain algorithms. So they have to generate a pseudo random number called nonce, which along with the combination of the last block goes into a hash function, in this case SHA-256, and has to generate and spits out a hash which has to meet a certain rule which has been generated by the algorithm. For example, here the first four numbers are highlighted at 0. So the miners, all the miners are competing against each other to find out that random number, which when combined with this last block, which has been proposed to the system, which when goes into this hash function generates this rule complying hash. So whoever generates this first has successfully completed that proof of work task, and this blocks then get validated from other people or other miners in the node, and the first one to generate also receives certain Bitcoin units in return as a reward for contributing to the system and upholding the validity of the system. So this is how mining works, and there are incentives for the miners, and that is why there are a lot of miners, and the economics of it incentivizes people to contribute computing power and generate these hashes. So for example, in essence, to alter the entire blockchain, someone has to have a lot of computation power to regenerate hashes of the entire blockchain if they want to alter any of the block which is in the history. If they want to alter any of the block, they have to generate hashes of the subsequent blocks, and that has to be very fast. And this process, for example, in case of Bitcoin, takes around 10 minutes for generating this proof of work successfully. So economically, the computation power that goes in, the computation infrastructure or hardware that goes in, does not make sense for someone to attack the blockchain for now, unless we have a very high computation power where we can generate all these blocks or all these hashes very fast in less than 10 minutes. So then the other thing is the proof of stake. So in the proof of work, how that environment or the energy equation comes in play, which is recently debatable, is people have built huge farms which are using energy equivalent to entire countries. For example, there have been certain like if you combine the total energy that goes into Bitcoin mining, it can power the entire countries like Hungary and New Zealand. So that is the amount of energy that goes in, and that is why this is deemed to be not a very efficient way to contribute to the system. So the next best algorithm or the next algorithm that exists for contributing to this is proof of stake. So in proof of stake, what happens is, instead of distributing it to miners, what happens is that it gets distributed to the stakeholders who have a certain threshold stake in the cryptocurrency. For example, there are people who own, say, 100 units of that cryptocurrency, or 1,000 units, or 1 lakh units of that cryptocurrency, will randomly be chosen because they have a stake in the cryptocurrency. They have something to lose if they act maliciously, and that is the core principle. Ask them to solve ask them to validate those blocks, and they'll act in the rational interest of themselves to protect their economic values, which is tied up in that cryptocurrency, and that is how it gets selected. So that is proof of stake, which is a very popular algorithm which takes away a lot of disadvantages of using a blockchain or a proof of work in validating a blockchain. And yeah, so the proof of stake, but there are certain other problems with proof of stake where the rich people will get rewarded for validating more and more blocks, will eventually keep getting richer and keep getting more these blocks for validating. So all these things are questionable, which people are trying to solve using different variations of these algorithms, and those are still in infancy, and people are trying them out. So again, these are unalterable mechanisms where the ledger is maintained in a decentralized way. People cannot alter it. These are immutable. Though there is an existence of people do generally create forks of these blockchains and can alter those blockchains, but the original blockchains still remain unaltered. So these are the two popular mechanisms how these validations in the blockchain are done. Just to give an idea, so finance and decentralized finance technology is one of the most popular use of blockchain, and Bitcoin has been at the helm of it. And like here is the landscape, how it looks in terms of fintech and a lot of blockchain utilizing technologies. But the applications and uses of these blockchains are immense. It can be used across a lot of non-financial use cases like healthcare, insurance, and all, which Jaivardhan will be talking in the next part of this podcast.